Bench testing a 1959-1960 Cadillac non-fog light option headlight switch, serial number HS12182025. Offered by TT Parts Rebuilding. Run-up test. Test number 1, tail and parking light operation. Test number 2, tail and headlight operation. Test number 3, dome courtesy light operation. Test number 4, dash lights set low to high. Test number 5, circuit breaker test. And test number 6, switch terminals insulated from ground. During the run-up test, going to be using a fully charged battery. Under boost, right now we're reporting 12.79 volts. Under boost, we have 14.10 volts. Also going to monitor the rheostat temperature. Right now we're at ambient at 78 degrees. Test number 1, tail and parking light operation. First position, we have our tail and parking lights. I'm going to set our rheostat to mid-range and off. Again, first position, tail and parking lights. Our tail and parking lights and off. Test number 2, tail and headlight operation. First position, have our tail and front parking. Second position, we see that the front parking lights come off and the headlights come on. Back to first position and off. Test number 3, dome courtesy light operation. First position, we have our parking and our tail lights, dash lights. And rotate the rheostat and turn on the dome courtesy light. By grounding this tab, we see have an indication of dome light, courtesy light operation, and off. Second position, light position, rotate the rheostat stem, and we see we have an indication of dome courtesy light operation, and off. Feature is also available with the headlight and the tail lights are off. By rotating the stem, we have an indication of dome lights and off. Test number 4, dash lights set low to high. First position, we have our dash lights here. I'm going to rotate the rheostat to the dash light off position. I'm going to just come to the dim side of the rheostat. We're at 80 degrees Fahrenheit. Go to mid-range. See the brightness of the dash lights come up. Too bright. Full bright. Back to dim. Mid-range. Too low. And off. Second position, headlight position. Rotate the rheostat to dim. Mid-range. Bright. Full bright. And off. Test number 5, circuit breaker test. Telco Remedy headlight switches had a built-in circuit breaker. It's a bimetallic contact arm, connects the battery to the switch body. Can demonstrate how that would work in the event of an overheating, say in a situation where there's short in the wiring. I'm going to put the switch in first position and simulate expansion of the contact arm, and see that the switch is disconnected from the battery. This protects the vehicle wiring and the switch body. Second position, that feature is also available in headlight position. Going to simulate expansion of the contact arm. By overheating, we see that the circuit is broken between the battery and the switch, protecting the vehicle wiring and also the switch. Back to first position and off. Test number 6, switch terminals insulated from ground. During this test, I'm going to use a standard 12-volt test light, and we see we have continuity back to the battery at the switch chassis. I'm going to demonstrate that switch terminals are insulated from ground by probing each terminal. Here we have our terminal to to the dash lights. Here is our battery feed. There's no continuity back to the battery. Headlight, no continuity back to the battery. Tail lights, no continuity back to the battery. Parking lights, no continuity back to the battery. This is our courtesy light ground. We have no continuity back to the battery. We only have continuity back to the battery at the switch chassis. So at the dash light terminal, this is a dash light feed to the rheostat, no continuity. Battery, headlight, tail light, and parking, and courtesy light dome connection. There's no continuity back to the battery. The only continuity we have back to the battery is at the switch chassis. This demonstrates that the switch chassis is connected to ground. The switch body is insulated from ground.